All right, we're back, section 4.3 today, and what we're looking at is factoring. So when we're talking about factoring in section 4.3, we're really talking about one of the major concepts in all of algebra 2 is factoring, and factoring with variables. And so when we're talking about these things, there's some words, some vocab words that you need to know. One is monomial. And we're talking about a monomial, we're talking about something like 3x or 4x squared or 5zy. Those are all monomials. The key part there being mono, right? Mono a mono, man on man. That's one. When we talk about binomial, we're talking about something like 3x plus 4. That's a binomial. It has two parts, just like your bicycle has two wheels. And then trinomial would be like a tricycle. 3x squared plus 4x plus 7 has one, 2, 3 parts. All right. A quadratic equation is kind of what we already talked about when we have something like this: ax squared plus bx plus c. Remember we talked about that thing earlier, the quadratic formula. So the quadratic formula was x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a who. And that's how you'll solve a quadratic equation. You know, when it's set equal to 0, you got your b, a, c, and that's where all these letters will come from. The root of an equation is just the solution to a problem like this one. For what values of x would it be 0? And then the 0 of an equation is very similar to the root. What we're talking about is on your graph, the root or the 0, same deal, where it crosses the x-axis at. That's going to be an important number to you. First thing we talk about is factoring expressions, and factoring is kind of like backwards foiling. And look up that FOIL thing again. Look up factoring online. Maybe somebody's got a great other ways to do it. But some of the ways we're talking about factoring here, what you're looking at when you're looking at this equation, and you want to break it down into x plus m and x plus n, you ask yourself, m times n. What two numbers, when I multiply them together, are going to equal -8? And then what two numbers, when I add them together, will be 7? So what are all the numbers that I multiply together to get -8? And then what are all the numbers that I add together to get 7? So if I look at the factors of -8, we got -1 and 8. And we got 1 and -8. Those are two factors. When I add them together, when I add these two together, I get 7. When I add these two together, I get -7. Other factors, other things that when multiplied together get me -8 are -2 and 4, 2 and -4. And so when we're taking a look at that, the sum of those would be 2, and the sum of these ones right here would be -2. So notice that when m equals -1 and n equals 8, you get that sum of 7. So that's what you really want. So we end up with x minus 1 and x plus 8. That's certainly one way to do that whole thing. You end up with m equals -1 and n equals 8, and that's how you would factor that out. Next, we're going to talk about some special factoring patterns. The special ones, the first one's called a difference of squares, which results in a plus b and a minus b. So if I had x squared minus 4, remember x squared minus 4 is x squared minus 2 squared. So that's a difference of squares, x plus 2 and x minus 2. This is a perfect square trinomial, and you might know this one, or you might memorize this one. It's not necessarily one that a lot of people see, and you're really not required to see it. So if it looks like that, it's a plus b squared, and if it looks like this, it's a minus b squared. That's pretty tough stuff, and it's not always necessary. So let's take a look at a couple of examples of those. First one, x squared minus 25. See, that's x squared minus 5 squared. So we have x minus 5 and x plus 5. And on the b one here, if you take a look, it's m squared minus 22m plus 121. And does that fit into my patterns of perfect square trinomials at all? Well, maybe you see that it fits here, that you have on b, there you have 2 times m times 11, and maybe you see that that's 11 squared. That would be kind of a stretch for you to see, but if you saw it, you'd get m minus 11 squared. And so because that's a little bit of a stretch when you look at that, I have other ways of solving that. What I like to do is use the quadratic formula to solve that. So in this situation, my a number would be 1, my b number would be negative 22, and my c number would be 121. And from there, I can just throw it in the quadratic formulas. But obviously, it's a little bit harder than that. So let's go through it. X equals the opposite of b plus or minus the square root of b squared minus 4a and c all over 2 times a. All right. And if I solve this big, long, nasty equation that I learned in Algebra 1 class, the quadratic formula, if I solve this thing, I'm going to use my calculator to do that. So let's grab my calculator real quick here. In my calculator, what I'm going to do is probably ought to turn it on first, or wait for it to turn on. Well, while we're waiting, let's there it goes. There it goes. So the first thing I'm going to do is what's called the discriminant, which is the stuff inside of the right here. That's called the discriminant. So I, on my calculator, am going to do parenthesis negative. Looks like it's reacting really slow today because we have too many things running on the computer all at one time. I thought this program was going to be better than the one we had yesterday. That's why I put it on there. So let's do it by hand. That's okay. 22. All right, a little too slow for us. So let's get rid of that thing. Let's go to 22 squared. So 22 times 22 is 44, and 44. I get 484 there, and I guess I got a handy dandy calculator right here that I could use. Let's just use that one. So we have 22 squared. It's a negative 22. So if I put my parenthesis there, and I do 22 negative, and I end parenthesis that thing. When I square a negative 22 times a negative 22, I end up with a positive 484. And what I have to do is multiply that by the B and C number. I have to subtract it from 4 times A, which is 1, so that doesn't really matter. But that 121 is positive. So I end up with 4 times 121, which is 484. So I have 484 minus 484 ends up being 0. So I am 22 plus or minus 0 all over 2. Well, 22 plus 0 is just 22. That's 11. 22 minus 0 is just 22, and that's 11. My two answers being 11 and 11. When I go back up here, it's going to be m minus 11 times m minus 11. And we'll get into that more as we go. Take a moment and do number 1 and 2 and try to anti-FOIL those. Go ahead and pause and take a minute. All right, welcome back. When we look at this here, what numbers did you get that when you multiplied them together got 12, and when you added them together you got 7? Numbers to multiply together you get 12. 3 and 4, 2 and 6, 1 and 12. Which of those add up to 7? 3 and 4. So you end up with x plus 3 times x plus 4. This was a difference of perfect squares. X squared minus 9 squared, x minus 9, x plus 9. The zero product property is a it's a pretty simple one. If the product of two expressions is 0, then one of them or both of them have to be 0. That would make sense. If I said I'm multiplying something by a number and I got 0, well, one or both of them would have to be 0. Therefore, if a and b are expressions and ab equals 0, then a equals 0 or b equals 0. And then if you look at this one, it says x plus 5 times x plus 2 equals 0, then x plus 5 must be 0, or x plus 2 must be 0. If I solve x plus 5 equals 0 and I subtract 5 on each side, I end up with x plus 5 equals 0, and I subtract 5 on each side, I end up with x equals negative 5, and obviously the other one is negative 2. And so that's you know, I think some of you are looking at that going, oh, well, obviously. But if we take a look at why that works over here on this next page, or why I need to know that, is because when I factor them, that's going to help me to find those zeros. So when I factor this one here, x squared minus 2x minus 15 equals 0, numbers that I multiply together to get negative 15 would be negative 1 and 15, 1 and negative 15, negative 3 and 5, 3 and negative 5. All those numbers. Which ones add up to be negative 2? Well, that's 14. That's negative 14. That's 2. Right there. Those add up to be negative 2. So I end up with x plus 3. And remember, your x's are always there. X plus 3 and x minus 5. What would make these 0? Well, either x plus 3 would be 0 or x minus 5 would be 0. So x either equals negative 3 or it equals 5. So the roots are negative 3 and 5. That means when I graph this part right here, the graph of it is going to go through the x-axis at 1, 2, 3, and 5. 1, 2, 3, 4, 5. And it's going to give me two of those points. It's going to make it easier to graph. Find the zeros of a quadratic function. Well, one of the ways you can find the zeros of the quadratic function is right on your graphing calculator. When we're using our graphing calculator to find the zeros, we're going to do this the old-fashioned way. I'm going to bring my handy-dandy TI-84 in here, and it looks like we got a pretty good picture here. So when I graph this thing, I get y equals, I go to my y equals button, and then I do x squared plus 5x minus 6, and then I'm going to do a zoom standard. And if I look at it, at those locations right here and right here, I have zeros. Now, I've shown you this one before. If you go to calculations, you can calculate a 0. And all your calculator asks you to do is say, put a point to the left of it, enter, put a point to the right of it so I know where to look, where the signs change at. And take a guess where you think it's at. And it says right there at -6. So one of my zeros is -6. The graph is going to pass through -6, 0. My other 0, when I calculate that, I go all the way over here because I see it right on my screen. Well, the other 0 looked like it was going to be at 1, and so 1, 0. You do that same method on over to there. If you look at it, as it goes over here, you see it's going to be right there, and you do the same method and you'll find it. So what are the numbers that multiply to get -6 and add up to 5? Well, -1 and 6 sound pretty good to me. Well, that's x minus 1 and x plus 6. You'll notice that these are just the opposite. So when you find those zeros on your calculator, it's always going to be x minus x minus. And so when I put in my 1 and my -6, that becomes plus. You go ahead and do 3 and 4 on your own, and I'll tell you what the answers are. They're 1 and 2 and -8 and 5, and we'll talk about those tomorrow.